functions. This was actually a quiz question for some of you already this year. Formally define production and cost functions. In doing so, describe precisely what each function measures. Can a firm be efficient if it does not generate its output according to its production function? So in this question, you got points for the definition of a production function, that it measures the maximum output possible for a given combination of inputs. You got points for the definition of a cost function. Cost function measures the minimum dollar cost of producing Q units of output. You got a couple points for noting that a firm cannot be efficient if it is not producing according to its production function. If you're going to be efficient, you have to be getting the most output you can for the inputs that you're paying for. So to be efficient, you have to be operating according to both your production functions and cost functions. The next question had to do with the shutdown decision of a private business in the short run. The question reads as follows. Suppose you own a restaurant and you have just contracted for 1 year to pay $2,000 per month for rent of the commercial space. The waiters, cooks, your own labor, food and utilities cost you another $3,000 per month. So, just to review here, we're saying the fixed costs are $2,000, the variable costs are $3,000. You find after a few months that you are taking in $4,000 per month in revenue. Do you continue to operate? If yes, for how long? If not, why not? What's the answer here? You should continue to operate for the length of the lease. That is to say, you got points for noting that although the restaurant is making a loss in the short run, at least the total revenues are more than covering the total variable costs. You're better off staying open than closing up shop. You then got points for stating that the restaurant should stay open only for the remainder of the contractual obligation of the lease, which is the remainder of the year in this case. So remember, the shutdown rule in the short run is that total revenues have to be greater than total variable costs. That's the same also, by the way, you didn't have to say it in this problem, but that's the same as saying that price needed to be greater than the minimum of average variable cost. Next question. Supply in a competitive market in the short run. In the short run, when other productive inputs besides labor are fixed, what is the expression that measures the marginal cost of production if W is the wage rate and MP is the marginal product of labor? What's the formula that we use to calculate marginal cost? It's the wage divided by the marginal product of the input, in this case labor. Remember, marginal cost is defined as the cost of producing not some arbitrary number of units of output. Marginal cost is defined as the cost of producing one more unit of output. So if I take the dollar amount that I have to pay to hire one more worker, that's the wage, and I divide by the number of additional units of output that that extra worker makes possible, as an approximation, I'm getting a formula that measures the dollar cost of producing one more unit of output. Dividing by the marginal product converts this dollar cost into an approximation for what it's costing to produce one more unit of output. Explain, therefore, in Part B, why marginal cost rises on the intensive margin. If I hire more workers, does that change the competitive wage rate for labor? No. If I hire more workers, though, what happens to the denominator of that expression? The law of diminishing marginal production or productivity predicts that as you increase the amount of labor that you're using, the denominator will go down. The marginal product of labor gets smaller. Since the marginal product is in the denominator, that makes the whole ratio go up. So diminishing marginal productivity is the same thing as increasing marginal cost. Question number 4. Cost minimization and profit maximization. Consider a pulp wood firm with 2 production facilities with the following marginal cost schedules. Facility A produces the first ton of pulp at $1 per ton, the second at $2, the third $3, etc. Facility B produces the first 2 tons of pulp at $1 per ton, tons 3 and 4 at $2, tons 5 and 6 at $3 per ton, and so forth. At a market price of $10, at an output price of $10 per ton for pulp, how much pulp should the firm produce in each of its 2 facilities? What's the key here to answering the question? Well, you got points for noting that the firm should produce a quantity of pulp at each facility so that price equals marginal cost. Right? As long as the output price is greater than the marginal cost of production, the cost of producing one more ton of pulp, you should increase your production. You want to stop once the marginal cost is equal to the output price. So you got points for noting that the firm should produce a quantity of pulp at each facility so that the price equals marginal cost. And you got points for calculating that this occurs at the following. You produce 10 units of pulp at facility A, and you produce 20 units of pulp at facility B. So if you write out the marginal cost schedules, you'll see that price is equal to marginal cost when you produce 10 units of pulp at facility A, and that price equals marginal cost. If you write out the table for facility B, you'll see that 20 units of pulp gets produced at facility B. The next question has to do with monopoly. For the following question, assume that the market demand function for the relevant good is described by P equals 100 minus 3Q. Marginal revenue. Remember, if you've got a straight line demand function, marginal revenue will also be a straight line, but it will be twice as steep, the marginal revenue curve or line. Excuse me. Find the profit maximizing output level for a monopolist with constant marginal costs of $10. What price does the monopolist charge for its products? So the key here, of course, is to equate marginal revenue and marginal cost. So the monopolist produces a quantity of 15 units of output. What price does the monopolist charge? Well, we go back to the demand function. We plug in the monopoly quantity of 15, and we find that the monopolist is going to charge $55 per unit that it sells. The next part of the question is about deadweight loss. You're supposed to compute the deadweight loss to monopoly. The first step in computing the deadweight loss is to compare the monopoly quantity with the economically efficient quantity. So how do we calculate the economically efficient quantity? We equate price and marginal cost. In particular, the economically efficient quantity, given these straight line demand and marginal revenue curves, is going to be twice that of the monopolist. In particular, the economically efficient quantity is 30, the monopoly quantity is half that, 15. The deadweight loss to monopoly, then, is an area of a triangle. You didn't have to provide a graph, but you could try to graph it. And in particular, the difference between the economically efficient quantity and the monopoly quantity is 15, 30 minus 15. The difference between the monopoly price of 55 and the competitive price, which is equal to marginal cost of 10, is 45. You do this calculation and you get a deadweight loss of $337.50. Next question, corner duopoly. So, students taking this exam were told that the formula for the Corno aggregate duopoly level is 2/3 times A minus C divided by B. The question is, this model that's discussed in the textbook, this model that we went over in class, what are these parameters? What's A, what's B, and what is C? So what is A? A is the vertical intercept of the inverse demand function. Right? The model that gave rise to this equilibrium solution is this one, where A is the vertical intercept and negative B is the slope. parameter C in the model that gave rise to this Cournot solution? What's C? It's the marginal cost of production. It's the per unit constant marginal cost. The next question asks in part B, how does the aggregate Cournot duopoly output level, given by this formula, how does the Cournot duopoly output level compare with the perfectly competitive and monopoly output levels under the same demand and cost conditions? The perfectly competitive level is greater than the Cournot level, and that is greater than the monopoly level. Part C, what is the market clearing price for the Cournot duopoly output? Show that the market clearing price is greater than marginal cost, assuming that the vertical intercept of demand is greater than the marginal cost parameter. So if I take the inverse demand function and I plug in the aggregate Cournot output level of 2/3 A minus C divided by B, then notice what I can do. The B on the outside of the parentheses cancels with the B here. And I'm left with A minus 2/3 times the quantity A minus C. That's equal to A minus 2/3 A plus 2/3 C. Right, I've got a minus times a minus, so I get positive 2/3 C. This is then 1/3 A plus 2/3 C. This is in fact greater than marginal cost. This is greater than C. Why? Because A is greater than C, by assumption. Right? If I got 2/3 C and I were to add 1/3 C to it, I would have C. But I'm not adding 1/3 C to it. I'm adding 1/3 A. And A is a bigger number than C. So I get, when I add these two terms together, I get a number which is greater than C. Next question. Bertrand duopoly. The market inverse demand function for a product is given by P equals 100 minus 2Q. There are two firms in the industry, each with constant marginal costs equal to $20 per unit. And there are no capacity constraints. Suppose further that the two firms will compete against each other just once in this market. In answering the following question, assume that the firm with the lower price than its rival will capture the entire market demand. If in equilibrium, the two firms charge the same price, assume that they split evenly the market demand at the price. If the two firms simultaneously choose price to maximize their respective profits, what will be the Nash equilibrium? That is, what prices will they each charge? This is the Bertrand model. Homogeneous products, each firm has the same constant marginal cost, no capacity constraints, they're just competing once. What do we know about the Bertrand equilibrium in this setting? What does each firm do? It charges a price in equilibrium equal to marginal cost, which in this context is 20 units of product, or $20, excuse me, $20. The next question. Oh, and what would the level of each firm's profits be? 0, right? If on every unit you're selling, price is equal to marginal cost, you add up all the units you're selling, you're making 0 profit on each unit, you're making 0 profits. Part 2. Would your answer regarding the duopoly equilibrium change if each firm could produce at most 40 units of output? Why or why not? Excuse me. The key here is to understand if each firm can only produce 40 units of output, does 40 units represent a binding capacity constraint? So here's what we have to ask ourselves. At price equals marginal cost, at price equals $20, how much would consumers like to purchase in total? So let's plug price equals 20 bucks into the inverse demand function and see what quantity consumers would like to purchase at that price. at a price of $20, consumers would like to purchase 40 units of product. So, if each firm can produce 40 units of product, do we have a binding capacity constraint? The answer is no. So nothing at all changes here. In this circumstance, if both firms were capable of producing 40 units of product at a cost of $20 a unit, we're going to get the same Nash equilibrium in price. You'll see there's a different answer to a similar question on the next midterm that we're going to turn our attention to. Let's take